In this video, we're diving into the context package in Go. You'll learn how to use context.Context for handling cancellation, timeouts, and concurrent programming. It's a crucial tool for writing robust and efficient Go applications. So, what exactly is a context? A context carries deadlines, cancellation signals, and request scoped values across API boundaries and goroutines. It helps you manage the life cycle of operations, especially in concurrent environments. The three key features of context are timeouts and deadlines, cancellation signals, and request scoped values. Let's look at how to create a context. You can create a basic context using context.Background. This is typically used as the root context for main functions and during initialization. Alternatively, you can use context.todo as a placeholder when you're unsure which context to use initially. Remember to replace it with a more appropriate context later on. Now, let's create a context with a timeout. We use context.withTimeout, passing in a parent context, such as context.Background, and a duration. Here, we're setting a timeout of 5 seconds. It is very important to always call defer cancel to release resources. This ensures that the context is canceled and resources are freed, even if the function completes before the timeout. You can then use this context in your operations. The context automatically cancels after 5 seconds. Next up is context with a deadline. Similar to timeout, we use context.withDeadline, but instead of a duration, we provide a specific point in time. First, we calculate a deadline 10 seconds from now using time.now.add. Then, we create a context with this deadline. Again, it is very important to call defer cancel to release resources. This type of context cancels at an exact time. It is useful when you need precise control over when operations should stop. Sometimes you need more control over when a context is canceled. That's where manual cancellation comes in. Use context.withCancel, passing in a parent context. This gives you a context and a cancel function. You can call the cancel function manually when needed to cancel the context. Alternatively, you can defer the cancel function for cleanup. It's useful for user-initiated cancellations or conditional stops. Now, how do you handle context cancellation in your code? Use a select statement with ctx.done to check for cancellation. In this example, we're waiting on either the context's done channel or a work channel. If the context is canceled, ctx.error will return an error and we can handle it accordingly. Always handle cancellation gracefully in long-running operations to avoid resource leaks and ensure proper cleanup. Finally, let's explore context values. Context allows you to store and retrieve request scoped values. Use context.withValue to store a value, providing the context, a key, and the value itself. To retrieve the value, use ctx.value, passing in the key. You'll need to type assert the returned value to its actual type. Context values are useful for passing request scoped data like user IDs, trace IDs, or authorization tokens across function calls.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.